Good day, Year 12, and welcome to the new unit. Our new unit is going to be on navigation. It's building upon the Earth Geometry unit, which you looked at last term. So if we want to look at the group of lessons, we have 5 lessons for you in this series. Number 1 is that we're going to review Earth Geometry. Then we'll be looking at accurate position description, looking at the nautical mile and the knot, then using the compass, and then using compass bearings and reverse bearings. So before we start, this unit is useful in locating yourself on the surface of the Earth, and it's also quite good in navigation. Just to get you warmed up, can I get you to open up to your textbook and have a go at skills check on page 251. Okay, so last year we looked at Earth geometry, and this is pretty well expected knowledge, so we just reviewed that just to refresh our minds. So if we look at a circle, we know that the circumference of a circle is just 2 pi r. So if we have a look at a question like this one, calculate the length of a great circle with a radius of 50 centimeters. Remember to state the knowns, state the unknown, that's what you're actually looking for. Use your strategy, so state your strategy, and then just substitute your knowns into the strategy and solve. So in this case, your strategy is 2 pi r, so we just substitute in that 50 centimeters, so it's 2 times pi times 50 centimeters, and that's the same as saying 314 centimeters. So if I have a sphere and that has a radius of 50 centimeters, the circumference of that sphere would be 314 centimeters at its greatest point. A little bit of vocab to review. A great circle. So a great circle is drawn on a sphere that has the same center as the sphere. Now the largest circle that can be drawn around the sphere is a great circle. So all of the lines going down, longitude, and the equator that goes across. A small circle is drawn on the sphere with a different center. So these circles are going to be smaller. So all of those lines of latitude or parallels of latitude, except for the equator, will be small circles. So that does bring us to the new term, which is latitude. So that's the distance north or south of the equator. So here's our equator, that's south, that's north. The longitude are the distances east or west of the prime meridian, which is found in Greenwich in England, and the meridians of longitude or lines of longitude are great circles, as I've mentioned before. So these red ones that I'm drawing over here in green are all meridians because they go through the point of Earth's axis, which is the North Pole and the South Pole. So we know that Earth spins, if you remember your junior science or geography, and it spins once a day. If you want to think about these small circles and great circles in a variety of different diagrams, here we go. So as I was saying, the equator is the only great circle of latitude, and you can see that here's the center of the Earth, and the radius goes to the center of the Earth. If it was a diameter, it would go just straight through the center. So the equator is the only great circle of latitude. That means that all the other circles of latitude are small circles. That means their radius is less than the radius of a great circle. If we're reading latitude and longitude, it's good to remember that lat is flat and longitudes are the longest lines. So we generally read latitude then longitude. If I want to look at a few of these points, so let's say, for example, point D here, I would go, how far north or south is this point? So I would read 10, 20, 30, 40 degrees north. So I would say that we are 40 degrees north. So this line of latitude here is 40 degrees north. Then I would read the longitude, and I would look at, here's my 0, and I can see that I am heading west. So 20, 40, 60, and there's our 60. So it's 60 degrees west. And that's how we read latitude and longitude. If I want to think about the prime meridian and the international date line, so we have the world is split into two halves. We have the east and the west hemisphere. So the Greenwich meridian is at 0 degrees. The international date line, although it's not an exact circle like that, you can see there's a few exceptions, and there was a recent one a little while ago. You can see that it's not an exact circle, and here is the international date line over here, and that's what I'm saying. It's not a straight line, it's a bit wonky, but it's 180 degrees. Now you don't say it's 180 degrees east or west, because, well, it doesn't make that too much sense. It's just the other half. You could, if you wanted to. It's like saying 0 degrees east or west. And so here's our prime meridian on the map. Let's have a look now. Let's locate a couple of places. So if I want to find Singapore on this map here, here's Singapore. I can see it's directly on 0 degrees. So it's on the equator. And that's the great circle. Remember, we read lat first, lat long. So 0 degrees north or south doesn't really make sense to say that, so we can just say 0 degrees. If you want to put a north or a south in, that's all right. Okay, now we need to estimate how far east it is. So we continue this line up, and it's about halfway in between 90 and 120. So if I say 120, take 90, that's 30. And then halfway between 30 is 15. So I just say, well, 15 and 90 make 105. So that's my estimation of the eastern coordinates of Singapore. So 0 degrees. If you want to put north or south in, as I said, it's all right. And then 105 degrees east. Now, have a look at the next question. What city lies approximately 30 degrees south? So here's my 30 degrees south, and I need to follow this line along. And then 30 degrees east. So let's have a look at 30 degrees east. Here's 30 degrees. I need to find the intersection of these two lines. And it looks like it's a South African town of Johannesburg, often referred to as just Joburg. If we're looking at distances on the surface of the Earth, remember distances on a great circle, 1 degree is the same as saying 111.2 kilometers. So if I want to find the distances on a great circle, it's just the angular distance, how many degrees is it from one to the other, and then multiply that by 111.2 kilometers. But if we're finding distances on a small circle, then it's a little bit more difficult. We just need to consider the cosine of the degree of latitude. And so we'll have a look at a little problem like that in a minute. Just remember, if the angular distance is more than 180 degrees, we're going more than halfway around the Earth. It's probably quicker to go the other way then, so you just subtract it from 360. So let's have a look here. What is the distance from Madrid to London? So where's Madrid? Here. Where's London? It's here. So, at an estimate, that might be what, 40, that 40 there, 50 there. So I'm saying, well, that's 10 degrees. And so we can see 10 degrees along the distance of a great circle. But remember, all our lines of longitude going up and down, and our equator, a great circle, so they're always going to be multiplying then by 111.2 per degree. So we're just saying 10 degrees multiplied by 111.2 kilometers per degree, and that will get us 1,112 kilometers. Let's have a look at the distance from Brisbane to Perth now. So Brisbane is here, Perth is here. Now it looks like we're on a small circle, and I'm estimating, well, it's probably about 155 degrees, 115 degrees along a small circle. I'll start again. It's 155, take 115, so that's probably 40 degrees along a small circle. So just remember, we go cosine, the angle of latitude, so cos 30, multiplied by the number of degrees, so we've gone 40 degrees along there, multiplied by 111.2 kilometers per degree, and that should get us 3852 kilometers. If we have a look at some worked examples now, so the first one is calculate the distance between 42 degrees north, 12 degrees west, 50 degrees north, and 12 degrees west. If we notice here that these are on the same longitude, that's the 12 degree west longitude. So we're actually just traveling along the surface of the earth from 50 degrees north down to 42 degrees north. So we're actually just traveling a total of 8 degrees. Now just remember, if the points are on the same side of the equator, we're just going to subtract the latitudes. So the answer is just going to be 8 degrees times 111.2 kilometers for a total of 889.6 kilometers. Let's have a look at the next one. But what if we're going to go from 42 degrees north now down to 50 degrees south? We are crossing the equator, so we are going from 42 degrees north down to 0 degrees, and then we're going to go down further to another 50 degrees, and so that's north, that's south. That's a total of 92 degrees that you're traveling. It's still along a great circle because we're on that line of longitude. So we're just going to add those two up together. So we have 92 degrees that we've traveled. Now 92 degrees times 111.2 kilometers per degree will give us 10,230.4 kilometers that we're traveling. In this example, we're going to look at calculating distances along small circles. So we are traveling laterally. So we're going across the face of the earth rather than up and down. So let's have a look at the first problem. Calculate the distance between 42 degrees north, 120 degrees west, and 42 degrees north and 70 degrees west. So you can see 42 and 42. I'm thinking about the earth, that's the equator. If there's a small circle of 42 degrees, and that's north. And I'm just traveling from 120 degrees west to 70 degrees west, so I'm heading towards the prime meridian, but I'm not crossing over the prime meridian, so I'm traveling on the same side of the prime meridian, so I'm just going to subtract those longitudes, and that's a total of 50 degrees. Now it's along a small circle, so it's 50 degrees multiplied by 111.2 kilometers, and then the cosine of the angle of latitude, so which is cosine 42 degrees. So 50 times 111.2 times cosine 42. And that should give me a total of 4,131 kilometers. Let's have a look at the next one. Calculate the distance between 42 degrees north, but this time I'm going 120 degrees west and crossing the prime meridian. So I'm at 270 degrees east. So I need to add these longitudes. So I am traveling 190 degrees. We have another issue here that 190 degrees is more than halfway of the surface of the Earth. So it's going to be easier just to travel around the other way. So 360 degrees take 190 is 170. It's easier to go 170 degrees rather than 190 degrees around the surface of the Earth. You're going to save yourself 20 degrees worth of travel. So we have 170 degrees multiplied by 111.2 multiplied by the cosine of the angle of latitude, and this time it's 42 degrees, same as before, and that should give us 14,048 kilometers. Okay, your turn to have a go at this. So open up your books and have a go at this. Pause the video. And there's the answers. And now I'd like you to work on exercise 5A, please, on page 253. Thank you.